Welcome to our MRU YouTube channel. We hope you enjoy the content. Please like this video and subscribe to our channel if you haven't done so yet. We are often asked, how long do electrochemical sensors last? Depending on the sensor type, there is more than one answer. We will cover that shortly.
In this video we will not look in detail at how an electrochemical sensor functions, but in brief, a sensor has chemicals for a specific target gas inside an enclosure that will react when exposed to this target gas, giving out a signal that can be used to display a gas concentration.
We are using electrochemical sensors for oxygen, carbon monoxide, nitric oxide, nitric dioxide, sulfur dioxide, hydrogen and hydrogen sulfide. They are small and light and are very good for typical combustion and emission measurements.
Sensors have come a long way when it comes to longevity. We offer oxygen sensors that have a typical lifespan of up to 5 years if they are used for their intended purpose. In general, we can say that the oxygen sensor's shelf life is defined by age and not so much by usage. That being said, it is not wise to store an oxygen sensor over a long period of time. In fact, we see that an oxygen sensor that is used frequently lasts longer than sensors that are only used periodically.
But this is only for the oxygen sensor. All other sensors like a carbon monoxide sensor or nitric oxide sensor have other limitations. Under normal circumstances, these sensors can also last 3 and up to 5 years. However, there are some other factors that shorten the sensor lifespan. Let's have a look.
I always like to explain the sensor life compared to a bucket of water. A new sensor is like a full bucket of water. Every time the sensor is exposed to gas, a reaction inside the sensor takes place. Compared to a bucket of water, some of the water is removed. The higher the gas concentration, the more water is removed. That means measuring lower ranges gives a longer sensor life.
A sensor is designed for a certain target gas and is designed for certain limits. In the data sheet of your analyzer, you will find the ranges of the installed sensors. For example, a CO sensor has a nominal range from 0 to 10,000 ppm with a short-term overload allowance of up to 20,000 ppm. And a nitric oxide sensor has a nominal range from 0 to 1,000 ppm with a short-term overload allowance of up to 5,000 ppm.
Now, let's first have a look at these ranges. Here, for the CO sensor, the nominal range is 0 to 10,000 ppm of CO. This is the typical range the sensor should be operated in. This is also the range where the sensor has its best accuracy.
Then there is the short-term overload range of up to 20,000 ppm. Meaning, the sensor can be operated for short time in this range. However, the accuracy is not as good as in the nominal range, and more importantly, this will shorten the lifespan of the sensor if done frequently. Operating the sensor frequently in the overload range will stress the sensor and the sensor deteriorates much faster. Operating the sensor above the overload allowance will destroy the sensor.
The CO sensor is the most likely sensor that sees higher target gases. A bad or very bad combustion process can have CO values that are way beyond what is normal. An experienced boiler service engineer will notice that on site and will troubleshoot this before making any measurements with an analyzer. However, since the CO sensor is the most vulnerable sensor for your application, most MRU analyzers have a CO sensor protection function. This ensures that the CO sensor is not overexposed to its target gas, even if a measurement is performed at high CO concentrations in the stack.
And here is how it works. You are performing a measurement not realizing that the CO concentration is too high. Analyzers with active CO protection will sample the gas into the analyzer. This gas is pumped to the installed sensors and each sensor reacts to its target gas. The CO sensor, however, has a user-definable CO threshold, which is factory set to 500 ppm but can easily be modified by the user if needed.
Let's say you are inserting the probe into the stack and there is a concentration of 8,000 ppm of CO. The analyzer will extract this gas using the gas pump and then pump the gas to the individual sensors. The CO sensor will soon read CO values that are higher than the CO threshold and will then immediately activate a secondary air pump which will dilute the extracted gas and prevent additional gas from entering into the CO channel. This function will also be displayed on the analyzer display, showing that the CO threshold has been reached and that the CO protection pump is active. All other sensors are not affected by the CO purge, oxygen, nitric oxide, and all other installed sensors will keep reading the undiluted gas. This CO sensor protection gives you peace of mind and will lengthen the lifespan of your CO sensor.
And now some other factors that can reduce the lifespan of your sensors. Never operate the analyzer inside the transport case. When doing that, the exhaust vent for the sensors will be blocked and no sufficient gas flow is possible. That is bad for the sensors.
Extreme heat and cold can damage a sensor as well. Don't transport your analyzer on the bed of your pickup truck, where direct sun can heat up the transport case and analyzer. And in wintertime, don't leave your analyzer in your truck when temperatures are extremely cold.
And last but not least, after a measurement, it is wise to ensure that there is no more gas in the analyzer. Wait till all measured values are back to 0, or 21% for oxygen, then let the analyzer run 1 more minute before shutting it down. Gas inside the analyzer will make the sensors react chemically, even if the analyzer is turned off.
We do our part to ensure a long sensor life. You can be a contributor as well. In general, it is fair to say that the O2 sensors has a lifespan of plus or minus 5 years. All other electrochemical sensors have a lifespan of plus or minus 3 to 5 years if treated well.
Please feel free to reach out to us for further information. Thank you for watching. Please don't forget to like this video and subscribe to our YouTube channel.